Okay, so here's a bit of a recap on what we were looking at yesterday. We were sketching parabolas and we were looking at it in terms of transformations. So we know our basic parabola is of the form y equals x squared. So there it is. Now the vertex is the bottom point. And so our vertex is at 0, 0, which is the bottom point there. There it is. So that's your basic parabola, and it actually goes on forever, even though my snip doesn't show that. It goes on forever. Things to notice that we talked about is because x is squared, whenever you square a number, I don't care if it's a positive or a negative, you'll get a positive. So that's why all your y values are positive. And it's also symmetric because if you compare like the square of 2 and the square of minus 2, they're both 4. If you compare the square of 3 and the square of minus 3, they're both 9. So that's going to give you your symmetry. So those 2 points we talked about, the square of 2 is 4 and the square of minus 2 is also 4. So that's where the symmetry is coming from. Now let's have a look at doing a reflection. So how do I get this? All I've done is I've made all my y values negative. So whatever x is, it gets squared, alright, that's y equals x squared. But then if I make them all negative, see this negative? I've made all my y values negative. That turns the whole thing upside down. Vertex is still where it was. Vertex is the only point actually that's still where it was. Everything else went negative. So that transformation is called a reflection, and it got reflected through the x-axis. See, that's our axis of reflection. Now let's have a look at other transformations. So here, on the left, let's have a look. So my normal y equals x squared, we remember, if we drag this back a bit, just can you see that the normal y equals x squared has its vertex at 0, 0, and it's symmetric about the y-axis, right? So what's going on with this one here on the left? It's been shoved over in an x direction, hasn't it? It's been pushed or translated or shifted. So that's why I've said down here a shift or a translation of 2. So it's gone and been pushed 2. Let's have a look at that here. Zooming up for a minute. See, it from the vertex used to be there. Guess what? It's over there now. So it got pushed by 2 in the x direction. Now what does that do on my equation? Well, that means I need to adjust my equation now. So why have I got x minus 2? Well, let's put x is 2 into this equation. If I put 2 in there, I'll have 2 minus 2, which is 0. Yep, that's correct, because this vertex wants to have a 0 y coordinate. So that's right. So that's why it's not y equals x squared anymore, it's y equals x minus 2 squared. So that's showing the shift on the x. See, there's a shift of 2 on the x. And the vertex is now at 2, 0. So there's your vertex. It's now at 2, 0. Okay, now let's look at this other one I've got here. This one has been shifted that way. It's gone up. See that? So that's actually a vertical shift of 2. So the shift isn't on the x anymore. The shift is on the y. So instead of y equals x squared, which was my basic one before it got moved anywhere, I've now had to adjust the y. It got shifted. So that's why I've got here y minus 2 equals x squared. It's got a shift of 2 in the y direction. And where's the vertex? The vertex is right there, which is at 0, 2. Okay. Now let's have a look at another one here. This one's got the shift in both the x and the y at the same time, so your vertex ended up going there. So it's no surprise when you read it off that it's going to be 2, 2, because the vertex used to be here, and then we went over by 2, and then we went up by 2, over by 2, up by 2. That's what this diagram's trying to show you, that we picked the whole graph up and moved it. And the point that I was interested in as I was doing that was the vertex. That's a good reference point to show when I move the whole thing. I may as well just pick a point of interest and move it. Everything goes with it. Okay, so that's that one. So that's the shift. You can see the shift there is on the y and the x now. So the basic y equals x squared has now got a shift on the y and on the x. Alright, let's have a look at another one. Now this one, so here's your original vertex. I've done it in the dotted. That's your normal y equals x squared curve. Look at this. On the x, it went over by 3. That's what I'm talking about there. And on the y, it's gone up by 1. So we went 3 that way and we went 1 that way. So that's what I'm talking about there. So can you see that I've got a shift in the x direction of 3 and a shift in the y direction of 1. So this y equals x squared here is now got a shift on the y and a shift on the x. Okay. Alright, so here's the question. If y equals x squared is translated minus 2 in the x direction, so that means I'm going backwards 2, and 3 in the y direction, so up 3. Okay. What's its equation? Okay, so we're going to go up 3, so I'm going to shift it 3. And backwards, so I'm going to shift it by a negative 2. Right, remembering that the basic is y equals x squared, and then I do shifts. Okay, so now this y minus 3 is the same as going to be x plus 2 all squared, because a minus minus is a plus. So there's your equation. Let's sketch it. Okay, so got to go. We're picking it up from here. Like this is your normal y equals x squared 1. And we've got to come back 2 and go up 3. So that's where my vertex is going to be now. It's not there anymore. It's moved. So this whole thing is going to be sitting up there. Right through my working. Let's draw it a bit better. Maybe we'll move it over here. Oh, look at that. Let's move it here. So we're going to go minus 2, up 3. There it is. It'll still go through my working. At least it's red. Okay. So can you see how that's happened? Now, wouldn't it be nice to know what that is there, that point there? How do you get that? What's your x-coordinate right here? Isn't it 0? And we're going to figure out what that is in a minute. So if x is 0, alright, we said this is the equation. Let's get a different colour. We said this is the equation. Let's put x is 0 in, okay? So this is x equals 0. So that's going to tell me that y minus 3 is 4. 4, so that means y is 7. Okay, that must be 7 then. Okay, so that's the point there, 7. So that's a little bit about sketching a parabola, considering transformations. Most of them have been, for us, translations. The very first one was a reflection. Okay, thanks.